Right, this is part 2 of the standard deviation from the mean presentation, and therefore we look at now example 2. And our data is 2, 4, 6, 7, 9, 12, 13, 15, and 50. We're replacing the 17 with a 50. You can see it's quite big and it's quite far away from the original data. And so let's calculate the mean. Let's input our data. So let's go to our calculator, and let's see now. Let's just press AC, and we're going to go to mode, and we go to 3 to statistics. We go to 1 for one variable, and there's our one variable table. And so let's start inputting our data. So 2 equals 4 equals 6 equals 7 equals 9 equals 12 equals 13 equals 15 equals, and then 50 equals. Right, we press our AC, and now we go to our shift, and we go down to our statistics, and now we go to 4 for variables, and we go to 2 for our mean equals, and our mean is 13,11, and you'll see there I've got it recorded 13,11. Let's press our AC, and then we go back to shift, and we go to statistics. We go again to 4 for the variation, and now we go to number 3 for the standard deviation. 3 equals, and we get 13,6499, so we can round that off to 13,65. You see I've got it written there. Now, we then take our mean and add one standard deviation, and then we get 26,76. We subtract one standard deviation, it's negative 0,54. And so actually, if you look at our data, all of the data except that 50 is within one standard deviation. So this points to a problem. That's 89%, so that's far too much. Far above that, so our data is unreliable. So normally we would have to start the experiment all over again. And the data that is like the number 50, that is so far away from all the other data, is normally called an outlier. So that's the definition of an outlier. It can either be very, very big or very, very small. It's away from the other data that's given. So let's go over now to example 3. Given the example, the data now, you can see the data there, and you know this is a typical example here where the data can be given in any order. So that's also fine. Let's just go back to our calculator, and we go to 3 for statistics, and again 1 for the one variable. And so now let's start to input our data. It's 3 equals 4 equals 5 equals 5 equals 9 equals 9 equals 9 equals 9 equals 10 equals 5 equals 10 equals 10 again, and then 11 equals, and there we've got 13 bits of data. Let's press our AC, and we go to shift, and we go to stats, and then we go back to 4 variation, and let's check number 2 for our mean, and our mean is 7,615, so that we can round off to 7,62, and see there that that's exactly what we've done. And you can see 13 is our bits of data. So let's just double check now in terms of AC, and we go back to shift, and then we go to stat, the bottom, we go back to number 4 for variance, and now we look at number 3 for standard deviation. 2,65 is what we rounded off to, so there we go. And so if we add one standard deviation to the mean and we subtract one standard deviation, we get 10,27, 4,97. So let's just check the one below, 4,97. There's 2 below it because 3 and 4 are below. And 10,27, the only one that's above 10 is 11. So 3 of them are outside, and that means 10 are within one standard deviation of the mean. So that's 77% of the data. It's still above 68, but a little bit closer this time. And so that's how we calculate the standard deviation from the mean, and that's a bit on how we use it. Thank you.